Now let's look at something called functional notation. What do I mean by this? Well, normally when you write an equation, you'll write an equation as y equals to 4x plus 1. But if you actually draw this out, this actually turns out to be a nice little linear graph that looks like that. And you're probably saying, well, how do you know that? Hey, experience, trust me, I'm a mathematician. I know what I'm doing. Now, the cool thing that's interesting about this then is that being that this is a function, shouldn't we somehow describe this with some sort of notation saying, yeah, if somebody looks at this, it is a function, right? The notation that we use is this stuff over here. This is a symbolic notation used for writing a function, and we call it this, which we call it f of x. Some people call it f at x. I kind of prefer this f of x thing because I have an issue of being fat myself, and you know, that's just not polite, right? So let's just call it f of x. That's the most common one that you'll see. So how does this particular equation change? Well, simple. Wherever you see the y here, you're going to replace it with f of x. And what does this mean? This tells you that this is a function machine. What do I mean? This x and this x are related. So if I look over here, and for example, and I said I wanted to find f of 2, well, I replace the x by 2, and since those are related, that means that's replaced by 2. And look what you have. You have 4 times 2, which is 8, plus 1. BEDMAS tells you that that is, in fact, 9. It's the same thing as x, y coordinates in a graph, but the funny thing is, you're just using this beautiful thing called functional notation. And check this out. Because this x was 2, your output, which is y is 9, this now becomes a point on the graph. So here we go. I'm going to give you a bunch of examples here. And what we're going to do is we're going to go straight out and write them as functional notation. Because watch this. Look at this question. This is C and N. Well, you know what? This could be cost. This could be, let's say, the number of, I don't know, bubble gums you buy. I have no idea. But let's say this is cost number. Okay, so think about this. Doesn't cost depend upon the number that you buy? And the number you buy is independent. So this actually is your independent variable. This is your dependent variable. Look at that. So cost depends on the number that you buy. Which means this is a function. Cost is dependent on the number that you buy. Cool. Watch this. This is D and T, which is probably, if you did a little bit of science, that you're talking about distance and time. Okay? So distance, which is your dependent variable, is determined by how long you're going to walk for, or run for, or drive in your car, or drive in your spaceship. I don't know. But it depends on the time that you decide to drive for. So distance is dependent upon the time that you are traveling. So distance is a function of time, which is 4t plus 5. So in other words, all I'm doing is I'm getting rid of this thing and just replacing it by the functional notation. Last one. Check this one out here. Okay, here we go. To write the equation, you would write this as, okay, get rid of the y. Your function depends upon your x, which is your independent variable. You choose what your x is going to be. Your function, your output, is dependent on what you choose for your x. There's your dependent variable. There's your independent variable, right? Right. Okay, so let's start putting these to use. Here we go. The equation C equals 25n plus 1,000 represents the cost, C dollars, for a feast following, let's say, some sort of sports competition. N is the number of people attending. Okay, describe the function and write the function in equation notation. Well, wait a second. Cost then depends on N. There's your description. Cost depends on the number of people that are coming to your banquet. Think about it, right? So what does this mean? Well, chances are that the number of people, what would be the one thing that's one cost that's dependent upon the number of people? Maybe since this is a banquet, probably it's going to be $25 for every person that's going to be fed, $25 a plate. What's the 1,000? Maybe the 1,000 is for renting the hall. Interesting. Okay, so check this out. What if you got 100 people in attendance? Well, okay, here's your formula. 25n plus 1,000. Okay, now you know that the cost is dependent on the number of people. So now we're going to say C of 100. But wait a second. Wherever there was an N, there's an N. This means wherever there was an N, now put your 100. See that? Plus 1,000. 25 bed mass. 25 times 100 is 2,500. Plus 1,000. Your entire banquet is going to cost you $3,500. That's how functions work. Now, I got a question for you. How about we go in reverse? What if we go in reverse? What if I say that the cost of the banquet was $5,000? Okay, that's the cost of the banquet. I want to know how many people were at your banquet. Okay, so let's write down the formula. Cn is 25n plus 1,000, right? Okay, so you know that the cost of the banquet, it says right here, it doesn't give you the number, it gives you the cost. The total all cost is $5,000, is 25n plus 1,000. Okay, perfect. Solve it. Subtract 1,000 from both sides. Okay, let's extend this page here. Subtract 1,000. That works out. That cancels here, right? This gives you 4,000 equals to 25n. Now, all you have to do now is divide by 25. And if you divide by 25, that cancels, leaving you n equaling 2. Quick calculation in my head, and I've got 160 people. Okay, so you had 160 people attend this banquet, and it ended up costing you $5,000. That's how these questions work. So with that in mind, the next podcast is going to look at several questions like this to make sure that we can burn this idea into your brain. And how to represent Cn, and when do you substitute in for n? That's in the upcoming podcast, so stay tuned.